It is a code violation to have the garbage disposal and the dishwasher fed from a full wire feeder with a common ground and neutral when they are each on their own breaker. According to National Electrical Code Section 404.2c, appliances that have a neutral terminal and are supplied by a branch circuit that is grounded at the surface and has a grounded neutral conductor shall have the grounded neutral conductor terminated at the appliance. In this case, the garbage disposal and the dishwasher both have a neutral terminal and are supplied by a branch circuit that is grounded at the surface and has a grounded neutral conductor. Therefore, the grounded neutral conductor must be terminated at each appliance separately. The use of a common ground and neutral violates this requirement and is a code violation. This means each appliance requires its own dedicated neutral conductor back to the panel. The grounding conductor, however, can be shared if properly sized and installed. The reason for this code is to prevent potential problems with current flow. Sharing a neutral conductor can lead to overloading of the conductor, especially if both appliances are operating simultaneously. This overloading can cause the neutral conductor to overheat, potentially leading to a fire hazard. Furthermore, sharing a neutral can cause voltage imbalances and potentially create unwanted current in the grounding conductor. This can interfere with the proper operation of the appliances and create a shock hazard. The NEC aims to ensure safe electrical installations and prevent these potential hazards by requiring dedicated neutral conductors for appliances. Grounding and neutral connections are critical aspects of electrical safety. The grounding system provides a low impedance path for fault currents to return to the source, tripping the circuit breaker and preventing electrical shock. The neutral conductor carries the unbalanced current back to the source. When these systems are not properly installed or maintained, they can create dangerous situations. For instance, if the neutral conductor is broken or disconnected, the voltage on the connected appliances can rise significantly, posing a shock hazard. Similarly, if the grounding conductor is not properly connected, fault currents may not be able to return to the source, increasing the risk of electrical shock. In the case of a dishwasher and garbage disposal sharing a neutral, the primary concern is the potential for overloading the neutral conductor. These appliances often operate at or near their maximum current draw, especially during startup or heavy use. If both appliances draw current simultaneously, the shared neutral conductor may exceed its rated capacity, leading to overheating and potentially a fire. This situation is further exacerbated by the fact that the neutral conductor is typically smaller than the ungrounded conductors, making it more susceptible to overloading. Additionally, a shared neutral can lead to voltage imbalances on the circuits. When appliances share a neutral conductor, the voltage drop on the neutral will be proportional to the total current flowing through it. If one appliance draws significantly more current than the other, the voltage drop on the neutral may be uneven, causing voltage imbalances on the circuits. These voltage imbalances can interfere with the proper operation of the appliances and potentially damage sensitive electronic components. Furthermore, a shared neutral can create unwanted current on the grounding conductor. In a properly wired circuit, the grounding conductor should only carry current during a fault condition. However, when appliances share a neutral conductor, a small amount of current can flow on the grounding conductor under normal operating conditions. This is because the shared neutral conductor creates a parallel path for current flow, allowing some current to bypass the neutral and flow through the grounding conductor. While this current is typically small, it can still interfere with the proper operation of the appliances and potentially create a shock hazard. To avoid these potential problems, the NEC requires that the appliances with a neutral terminal be connected to a dedicated neutral conductor. This ensures that each appliance has its own independent path for current flow, preventing overloading of the neutral conductor, voltage imbalances, and unwanted current on the grounding conductor. In summary, the NEC requirement for dedicated neutral conductors for appliances is intended to protect against electrical hazards. By ensuring that each appliance has its own independent path for current flow, the code minimizes the risk of overloading the neutral conductor, voltage imbalances, and unwanted current on the grounding conductor. This helps to create a safer electrical installation and protect people from electrical shock and fire.